In this video, which is the first in a three-part series, I'll discuss how to go about screening your data. Very often, when you have data collected, there might be some problems with the data, and before you can go on with conducting additional analyses, you need to make sure the data is screened and cleaned so that it would then be appropriate for further analysis. So we're going to discuss in these three videos how to assess your data for completeness, accuracy, and normality. In this part, we're going to focus on completeness of data and how to deal with missing data. But the first question is, why do we have to go about screening the data and cleaning it up? Well, we want to make sure that our data set has all the values that we expected. So if we collected data on 100 participants, we want to make sure we have data on 100 participants. We also want to make sure the data that's been collected is feasible and reasonable in its value. So a lot of times, due to either data entry error or some other mistake that could be occurring as we collect the data, we might end up with values for a variable that just don't make any sense or aren't appropriate for the sample that we want to collect. So for example, if we want to collect a sample that has individuals between the ages of 18 years and 35 years, and somehow we end up with a participant who's 50, we want to be able to identify that participant who doesn't belong in our data and then deal with that. And then lastly, we want to make sure the data is appropriate for inferential analysis. And mostly what we're talking about here are, does the data meet the assumptions for doing different types of inferential analysis? For example, if you wish to do an independent t-test on your data, the data needs to meet the basic assumption of being normally distributed in order to do that type of t-test analysis. So that's what these three parts videos are going to focus on. And as I mentioned, the first part, we're going to focus on how to determine if your data is complete. And then if it's not complete, what are some strategies that we can utilize to deal with that? So when we're looking for completeness of a data set, we're really looking at, are all the data points entered? So if we know how many participants we're supposed to have in our data set, whether that's through some kind of a interventional trial or whether that's through a survey, we want to make sure all the data is entered. And so how we do this in Intellectus is when we run descriptive statistics, we're going to see a sample size that has been identified for that particular sample. In the Intellectus output, it's identified as your N, or the number of people, and you want to match that up, the value where you're presented with in the output, with how many you expect to see, and that will immediately tell you if you have any missing data points. Obviously, you can also scan the raw data to see if there are cells that are empty, that don't have a data point, whether that's a quantitative point or a qualitative point. Now, how do we deal with this if we have values that are missing? If we're supposed to have 150 data points and we only have 145, what do we do? Well, one of the first things you can do is if you're collecting data using some other method, like data sheets that were being collected by hand, or if you were doing a survey, you go back to your original survey data set and check those sheets to see if somehow the data that was supposed to be there didn't get entered, and then you can replace that. Now, if you've done that and you discover that there was data that just was not collected, and you wish to do what's known as an intention to treat analysis, in other words, you want to have data for all of your participants, we do something called imputation, and that's essentially replacing values that are missing. And so there's a couple different ways we can do this. If you're doing a pretest post-test sort of design, in other words, you've got data for a pretest and data for a post-test, and you've got missing data in your post-test variable column, then you can do something called the last value carried forward, or LVCF. And this is where whatever the pretest value was, we essentially carry that forward and assign that same value to the post-test. There are obviously pros and cons to that. The pros being it's easy, and you also know that your pretest value was an actual value that was collected, and then you can carry that forward. The downside to that is that that then essentially demonstrates there was no change for that particular individual. So in reality, they may have changed quite a bit, but when you carry that value, pretest value forward, it essentially shows that there was no change. They could have actually gotten worse as well, and carrying that value forward demonstrates that there was no change or no response to the treatment. So those are some of the downsides there. What you could do is assign, another option is to take the mean of the group that have values for this particular variable, and assign that mean value to the missing cell. And so what this has a tendency to do, it then assigns a value that's typical for that data set, and there's probably a fairly high likelihood that the actual missing data would be pretty close to the mean of the group. And so that way you're able to assign them a value that's probably pretty close to what the actual value would be. Now again, that's fairly easy. It gives you a measure that's within the area of the central tendency for that group of data. But again, it may misrepresent what the actual value would have been for that person had that data point actually been collected. And it does tend to kind of minimize the variance that you might have in that data set, which may be a good thing, it may not be a good thing. And it also tends to homogenize your sample a little bit, depending on how many data points, missing data points you assign the group mean. The last option, and the one that probably is the most effective and deals with most of these cons that we mentioned for the first two options, is something called imputation. And essentially what happens is the software develops a regression equation to predict what the missing value would be based upon data in the other variables. And so it creates a prediction equation that says if your height is missing, for example, based upon the data from the other data that's been collected, it then predicts what your height is or would be. And so this is fairly easy to do, and it's also a much more accurate predictor, potentially, of what the true value would be because it uses the other data available. And so this allows us to replace those values fairly easily and build out our data set to be complete. Now, usually there's a rule of thumb as to, okay, if you've got so much missing data, how do you deal with that? And typically the rule of thumb is if you've got between 5 to 10% of data within a given variable missing, then doing imputation is likely going to be appropriate. And you can also, if maintaining a certain sample size is not a concern for you, you can also trim those subjects. In other words, the subject that has a missing data just isn't included in the analysis. And so you can eliminate that participant from the analysis, or you can replace the missing data. And that allows you to maintain your sample size. So this becomes even more important when we have smaller sample sizes and we have a few pieces of missing data. Replacing a missing data value will help you maintain the sample size that you're shooting for. So again, there's pros and cons. Trimming, just eliminating someone from the analysis because they don't have data is also easy to do, and you generally cannot go wrong doing that unless there are a lot of individuals that have missing data. And another element to this is trying to determine if the data is missing at random or not at random. So an example of this might be if there's a particular question in a questionnaire that participants just don't want to answer for some reason, whether it's sensitive information or the question isn't clear, so they're not sure how to answer it, so they just don't answer it. And so that's data that's not missing at random, and so that becomes problematic because it could be creating some bias in your data set. If data seems to be missing at random, then trimming or replacing the missing data through one of these methods is perfectly appropriate. So the next thing I want to do is demonstrate within Intellectus statistics how we would go about assessing the completeness of the data, and then how we might go about replacing missing data through any of the methods that we talked about. So you can see here we've got a data set that has some numeric data, and we're just going to be working with one of the variables here. reading number 1. And so our first step is to go into the analysis menu and choose descriptive statistics. And so we want to choose the variable we're interested in this case, reading 1. And you can do multiple variables at the same time. It doesn't just have to be one at a time. We go ahead and click confirm and then click calculate. And in this case, you can see the output table here at the bottom of the page. We've got our variable reading number 1, we've got our mean, standard deviation, we've got a minimum, a maximum value, and so on. And so what we want to focus in is the N. We want to see how many participants actually have a data point. And so we're going to pretend that in this case, we were supposed to collect data on 150 participants. But as we can see here, we only have data on 146. So that means we have 4 missing participants. And so we then need to decide how we're going to handle this. Now, this might not sound like a lot of people relative to 150, and it really isn't. And if maintaining a certain sample size isn't of a concern to us, we can just accept the fact we have 4 missing pieces of data and move on with our additional analysis. But if we do want to determine or bring the sample size up to that 150 amount, then we can start to investigate some of our options. So one of the first options, as we mentioned, was to replace the missing values with the group mean. And so in this case, we have our group mean reported here, and it's 84.26. And so if we wanted to go about this process of replacing the missing data with the group mean, we could simply go back to our data and choose the edit data option. Okay, and we can find our missing data points and then enter in the value of 84.26. And then that would replace that missing piece of data. Now our other option, as I mentioned, is to replace this with imputation. And so this is where the software is going to predict what the value would actually be for that individual based upon the other data that's available. And so again, this is a fairly easy technique to utilize. So within the management menu, we're going to find the option for imputation. And we're going to click that. And so we're going to choose the variable that we want to impute or replace missing data for. And one of the things that Intellectus will do, it'll show us the only variables that actually have missing data, so we can very easily see which variables we might need to do this for. And then you also have the option to replace the variable. In other words, impute the missing values without changing or without creating a brand new variable. And the other option is to append a new variable, which means we're going to create another reading 1 variable with the imputed data. So we're still going to have our original variable with the missing scores, and then we're going to have a new variable with the imputed data. And that is the preferred option, is to create a new variable with imputed data, because very often when we have missing data within a variable and then we impute that, we want to compare, or at least report the difference between the non-imputed data and the imputed data, so that people can see if that appreciably changed the mean or the variance, the standard deviation within that variable. So it's always a good idea to create a new imputed variable, and so that's what we're going to do. So once we've selected the variable we want to replace the missing values for using imputation, we then click submit. And then what we'll see if we scroll all the way over to the right is we'll see now this new imputed data. It's got roughly the same name as the original variable, reading 1, but we can see it is now indicating that it's been imputed. So in other words, the missing values have been replaced. And so this allows us to replace those missing values quite easily, knowing that it's likely a very accurate replacement for what the actual value would have been for that individual. And so the first step in the data screening process is to determine if you have missing data. And if you do, you then need to decide how you want to deal with that. Either you trim those individuals, in other words, eliminate them from further analysis, or you replace the missing values through one of the three techniques that we talked about. So hopefully you found this video to be useful, and good luck using it in your own